Hello students, in our previous classes we have completed matrices and determinants chapter successfully. Today we are going to discuss about a new topic, that is limits and continuity, chapter number 5. In our plus 2 fifth chapter, 6, 7, 8, these 4 chapters comes under calculus. Calculus is nothing but a branch of mathematics which is going to play a vital role in our higher education. So that, and we have more weightage in our plus 2 also. From these 5, 6, 7, 8, from these 4 chapters, we have 30 marks weightage. Means very important concepts. In that, the first step means the first chapter we are going to discuss. In our regular classes, we discuss limits and continuity, exercise 1. How to find limit of a function at a particular point. We know when the limit exists, how to calculate the left hand limit, how to calculate the right hand limit, and when we can say the function is continuous at a particular point. That and all we discussed in our first exercise. So when we need to discuss about a limit, if there is a function f of x, when you need to find a limit at a particular point C, how can we find? We can say that limit extends to C f of x. Limit extends to C f of x. This is our limit. Always this limit is nothing but equal to the function f of c. Here the limit value and f of c value both must be equal. Whenever these two are equal, then only we can say the function is continuous. When limit extends to c, f of x is equal to f of c, then we say that it is a continuous function. Is a continuous function at the point C. Okay, when the limit exists, here we are discussing at the point C. When we have a number line, this is the point C. So left side of the value C is nothing but left hand limit. This is nothing but what? Left hand limit. This is nothing but called what? Right hand limit. So how to find the left hand limit? Left hand limit means x is less than c. Right hand limit means x is greater than c. How to find the left hand limit? Limit extends to c minus f of x. Right hand limit extends to c plus f of x. When the left and right hand limits are equal, means when the limit extends to c minus f of x is equal to limit extends to c plus f of x, then we say limit extends to c f of x exists. So left hand limit and right hand limit both must be equal. Then only we can say that limit extends to c f of x exists. Otherwise limit does not exist. And we have seen in our 11th class, first principle of derivative means limit h tends to 0, f of x plus h minus f of x by h. Using this is nothing but what? F dash of x means derivative of f. This is nothing but called first principle of derivative. This is nothing but called what? First principle of derivative. Using this first principle of derivative, we have derived the value of x, the value of sin x, the value of cos x, that and all. Derivative of x we have done, derivative of sin x we have done, derivative of cos x, derivative of 1 by x, that and all we have calculated in our class 11. Today we are going to continue the process of differentiability for different kinds of functions by using the product rule, quotient rule and different formulae. So this is just introduction. Today the sub concept in limits and continuity, differentiability, that we are going to discuss. What is differentiability, how to find the differentiability, and why, when and where, that and all we are going to discuss. Now our concept is differentiation. So what is the meaning of differentiation? Why we need to do the differentiation? How to do the differentiation, that we are going to learn in our present class. So let me explain the definition of a differentiation. F is a real function and C is a point in its domain. The derivative of f at C is defined by limit h tends to 0, f of C plus h minus f of C by h. So this limit, whatever the limit here we are finding, this limit is nothing but called derivative of the function f. Here what we given, f is a real function. What is the meaning of real function? For every function we have a domain and we have a codomain. Where the domain and codomain both are real numbers, where the domain and codomain are real number, that function is known as real function. We have different types of functions. A few functions we have seen in our class 11th also. Now real function, we have real variable function, real valued function and real function. So what is the meaning of real function means? For example, if there is a function f maps R to R. So here R is nothing but real numbers which is a domain, and again here R is real number which is a codomain. The function is defined from a real number set to a real number set. So this kind of function is known as real function. And C is a point in its domain. What is the domain here? Real number set. So in that real number, C is nothing but one point. So now we are finding the derivative of f at a particular point C is limit h tends to 0, f of C plus h minus f of C by h. This limit is nothing but called derivative of the function f. And there is a condition of that. Here the limit must be exist, provided this limit exists. When the limit exists, then only we can have the derivative. If not, suppose limit does not exist, then what will happen, sir? When the limit does not exist, we can say that derivative also does not exist where at a particular point of C. Where the limit exists, derivative exists. Where the limit does not exist, derivative also does not exist. So derivative does not exist in the sense where the derivative is not exist at a particular point of C. And we know how the limit exists. Limit exists. That and all we have seen in our first exercise, limits and continuity. Even in class 11th also we have seen the limits problem. How to find the limits for different functions and what are the formula, everything we have seen, and continuity also we have seen, and how to find the left hand limit, right hand limit, and the function value, everything we know. So in that case, when limit exists, derivative exists. When limit does not exist, derivative also does not exist. Derivative of f at c. Now what we are finding? Derivative of f we are finding at the point c is denoted by f dash of c. Here f dash of c indicates what? Derivative of a function at a particular point c. Derivative of a function at a particular point c. Or the derivative is also denoted by d by dx. What is x here? X is nothing but a variable. Means the function we have in terms of x. Now the function we are derivating with respect to the variable x. D by dx of f of x, which means there is a function in terms of x. That function we are going to differentiate with respect to the variable x. After differentiating, we need to take x value as c. That is nothing but differentiation. So the function defined by f dash of x is equal to limit h tends to 0, f of x plus h minus f of x by h. This already we have seen in our class 11. This is nothing but called what? First principle of differentiation or first principle of derivative. Using this, in class 11 we have derived what is the derivative of x, what is the derivative of sin x, what is the derivative of cos x. That and all we have seen in our class 11. This is nothing but called what? First principle of derivative. F dash of x is equal to limit h tends to 0, f of x plus h minus f of x by h. This is nothing but called first principle of derivative. What we can call it as first principle of derivative. Now this is nothing but differentiation. So the original definition of differentiation is the process of derivative is nothing but called differentiation. So we are derivating. What we are derivating? We are derivating a function value where at particular point. So calculating the derivative is nothing but called differentiation. So the process of finding the derivative is called differentiation. That is our concept, differentiability. So whenever we have a function, definitely the function maximum will have differentiation. It is derivable. So where it is derivable, at what point it is going to derivable, that and all we are going to observe in this class. Hope you understood what is the differentiation. Differentiation is nothing but the process of finding the derivative is called differentiation. While doing the differentiation, so we have different formulae. So we have seen. What are the formula? So when the composite functions are there, or two functions are added, two functions are subtracted, and we have product rule and quotient rule, different formulas are there. That we see now. By using those formulae, how to solve the exercise problems also today we discuss. Here we have some list of formulae how to differentiate the given functions. For example, when we have u and v are two functions, between these two functions when we apply the fundamental operations, what are the fundamental operations? Addition, subtraction, multiplication and division. So after performing the fundamental operations, then how to do the differentiation, how to find the derivative of the functions, that we are going to see here. This already we know. Just we are discussing once again. U plus v, adding the functions and finding the derivative. U plus v dash means what? Derivative of u plus v is nothing but derivative of u plus derivative of v. Simply we can write it as dy dx of u plus v is nothing but dy dx of u plus dy dx of v. This is nothing but the meaning of this. So u plus v whole dash means differentiation of u plus v function. So adding and finding the differentiation, or finding the differentiation then adding, both gives the same result. Here what we are doing, left hand side adding the function then finding the differentiation. Here what we are doing, finding the differentiation, then we are finding the sum. Both gives the same. Similarly, u minus v whole dash is equal to u dash minus v dash. It is also just like the same. What it is? d by dx of u minus v is nothing but d by dx of u minus d by dx of v. What is x here? X is nothing but variable. U and v are nothing but what? Functions. U and v are nothing but functions. X is nothing but variable. D by dx, the meaning of d by dx means differentiating the function with respect to the variable x. Differentiating the function with respect to the variable x. Whatever the variable we have, according to that variable we need to differentiate. For example, f of x is equal to 2x plus 3. Here what is the variable we have? X. So that I need to find df by dx, means the function here we are differentiating with respect to the variable x. For example, g of z, 3z we have. Here we need to differentiate with respect to z. So the differentiation is with respect to the respective variable. Whatever the variable we have in the function, with respect to that variable we need to go for the differentiation. Usually we discuss x or y or z or t. These are the variables we usually choose as a variable. So u plus v whole dash is equal to u dash plus v dash, u minus v whole dash is equal to u dash minus v dash, u into v whole dash, u into means product rule we can't do directly, that is the formula u into v dash plus v into u dash. This rule in this formula is known as Leibniz or product rule. We can call it as Leibniz rule or product rule. Next we have u by v whole dash is nothing but v into u dash minus u into v dash by v square. This is nothing but called quotient rule. This is nothing but called what? Quotient rule. Quotient means we are performing the division. So using these four formulae, we know how to solve the problems we have seen in our previous classes. And once again, we discuss a few problems based on these concepts. Here we have a few concepts based on the differentiability. Means a function f is said to be differentiable in an interval a comma b. Interval. So where we hear that word interval? In class 11, set theory concept. While discussing that set theory concept, we come to know that what are the intervals. So we have total 4 kinds of intervals. What are they? Closed intervals, open intervals, closed and open interval, open and closed interval. And you know what is the difference between closed intervals and open intervals and all. given here? Square bracket. Square bracket means closed interval, means including a and b between the values. We are going to select all the values. We are going to select all the values between a and b, including a and b. That is the meaning of closed interval. For example, when we have 2, 3, between 2 and 3, how many real numbers are there? Infinite. For that infinite, we are going to include the value 2 and also 3, means the boundary values also we are going to include. That is nothing but closed interval. So, if it is differentiable at every point of closed interval a comma b. So, when we need to say that a function is differentiable at this interval means it is differentiable at every point of in that particular interval. So, we have one interval a. In between how many points are there? Infinite number of points are there. At every point, when the function is differentiable, then we say that the function is differentiable at particular interval. If it fails at one point also, we can't say that it is differentiable at that particular interval. That is about differentiation. When we discuss about continuity, as in case of continuity at the end points a and b. So, when we want to discuss about that continuity, whether the given function is continuous or not, you no need to check about all the points of the interval. You can check only the end point. What is the starting point? A. What is the ending point? B. When the function is continuous at A and B, it is enough. But differentiability, we need to check at every point of the interval. So that is the differentiation between the differentiability as well as the continuity. That is the difference we have. So you need to observe the difference. Means when a function is differentiable at an interval, when the function is continuous at an interval. Differentiation means at every point the function has to be differentiated, has to be derived. Continuity means only at the end points. End point means starting and ending. What is the starting point? A. And what is the ending point? B. So, at the point A and at the point B, if the function is continuous, which means the function is continuous at the interval. This is about closed interval. Now, the same we have open interval. A function f is said to be differentiable in an interval a comma b. Here, what are the brackets we are using? Open brackets. Open bracket gives us opening interval, means here we are going to choose the values between a and b. Between a and b, we are not considering the value a and the value b. Excluding the values a and b. Here, including the values a and b. Here, excluding the values a and b. Closed interval means we have to include the end values. Open interval means we have to eliminate the end values. That is the difference between closed interval as well as open interval. Here we are discussing about open interval. When a function is differentiable at an open interval a comma b, means it has to be differentiable at every point. It has to be differentiable at every point of the interval. Then only we can say the function is differentiable. Whereas when we discuss continuity, the same concept. If it is differentiable at every point of a comma b, but continuity there is no discussion because we are not considering the end points. We are not considering the end point. Whereas here we are considering the end points. That's why we have end point A, end point B. Here we don't have the end points, so that we are not discussing about continuity in this case. Next, there is a theorem 3. Proof is not important, just know the statement of the theorem. If a function f is differentiable at a point C, then it is also continuous at that point. Means what? When a function, we know how to find the differentiation by using a first principle. Just now we discussed. So there is a function here. There is a function here. We are finding the differentiation at particular point C. We are finding the differentiation at a particular point C. When the differentiation is possible at the point C, then automatically the function is also continuous at the particular point C that they are asking. Means that every differentiable function is continuous. Means whenever you have a function, if it is differentiable at a point, which means that the function is also continuous at the particular point C. Function is differentiable means function is continuous. When function is differentiable, then automatically what you will get? Continuous. Means the function is also continuity. So that is the statement. If a function f is differentiable at a point C, then it is also continuous at that point. That is, every differentiable function is continuous. So, while discussing this continuous and all, if you want to get more clarity, you should have the perfect knowledge in our first exercise, limits and continuity. So, first you need to revise that limits and continuity. You have to perfect in that concept, then it is very easy. So without knowing what is called limit and what is the continuity means, definitely you will have more confused in this. So be perfect in the limits and continuity concept, then learn the differentiation. Then only you feel more easy the concept of differentiation. Otherwise it is very difficult. Our concept is derivatives of composite function. So what is the meaning of function? Functions chapter, that is there for our first chapter. You have functions, our first chapter. There we come to know the different types of functions. Now just let me explain briefly about composite function. In our chemistry, while doing any experiment in lab, we have different salts and acids. To do any experiment, we mix the salts and we mix acids and all. When we mix two salts, what we will get? Compound mixture. Similarly, composite function means combining of two or more functions. Combining of two or more functions. So how to combine and how to calculate those functions that we are going to discuss now. Composite function. What is the meaning of composite function? When there is f of x and when there is g of x function. F of x function and g of x function. Now I want to combine these two. I want to combine these two functions. When we combine these two functions, what we get? We get f of g of x or g of f of x. This symbol O simply we get as F circle G circle F. This circle indicates the composite function. That indicates the composite function. So what is that composite function and how to find that composite function? And when the composite function exists also, we observe here. Means that when f is from a function R to R, G is also a function from R to R. When we want to combine these two functions, here the codomain, here the domain, these two must be equal. First function codomain, second function domain, both must be equal. When the first function codomain and the second function domain both are equal, then this circle F exists. Then this circle F exists. For example, F maps M2 or G maps R to W. Here the codomain is real numbers and here the domain is real numbers. Then this circle F exists. Then what about F circle G? F circle G. F circle G means we have to write separately. What is the G function? We have R2 whole numbers and F function we have natural numbers to real numbers. Here what is the codomain? Whole numbers. Here what is the domain? Natural numbers. Are they equal? No, they are not equal. Means F circle G does not exist. F circle G does not exist. So when the codomain of the first function, domain of the second function are same, then this circle F exists. Here F is a function from natural numbers to real numbers. G is a function from real numbers to whole numbers. Here in first function codomain, second function domain both are equal, so that this circle F exists. Here the function consideration we come from right to left. So right to left, what is the first function? F. What is the second function? G. So right to left order we have to follow. So the first function F, codomain. The second function domain, both are equal, so that this circle F exists. When G is a function from real numbers to whole numbers, F is a function from natural numbers to real numbers, then what about F circle G? F circle G means first we should consider the G function, then we discuss about F function. G function, the codomain of G is whole numbers, the domain of F is natural numbers, both are different, so that F circle G does not exist, so that F circle G does not exist. Now let us see how to combine the functions. How to combine the function means how to find the composite of two functions. Let me explain. When we have f of x is equal to sin x, g of x is equal to x square. F of x is equal to sin x, g of x is equal to x square. If they ask find f circle G and G circle F, both they are asking to find. How to find? Let us see. F circle G of x first we are finding. You may ask, sir, here they did not mention anything. Why you have taken x? All the functions are defined by which variable? X. So that f circle G is also nothing but a function. When we are discussing about a function, definitely we have a variable. So f circle G of x. F circle G of x means f of G of x. G of x. What is the value of G of x? X square. What is G of x? X square. Now f of x is equal to sin x. Now f of x square. Wherever we have x should replace with x square. Here we have x, so that here also we have x. Here what we have the variable x square. So our function is nothing but sin x square. Now you observe here, it is a combination of two functions. One is sin x, another one is x square. Both functions we are combining, which is nothing but called composite function. So this is about f circle g. Now let us see what is g circle here. G circle f of x. G circle f of x means g of x is nothing but sin x. What is g of x function? X square. Wherever we have x, now in place of x what we have? Sin x. So our answer is sin x whole square, which is nothing but sin square x. So there is a difference. Sin x square is different. Sin square x is also different. This is about composite functions. This is about composite function. Now, how to differentiate these composite functions? How to differentiate these composite functions that we are going to discuss. How to differentiate these composite functions. For example, when you have u and v are two functions. When you have u and v are two functions. So now how to differentiate a composite function? Let us see. When you have u and v are two functions, let f is a real function. F is nothing but composite of v and u. V circle u means composite function of v circle u. Now how to differentiate is nothing but, let suppose t is equal to u of x. We are considering a different variable t. U of x is nothing but what? T. And if both dt by dx and dt by dt exist, we have df by dx is equal to dv by dt into dt by dx. Means what, sir? Means t is nothing but what? Function u. First we are differentiating the function u with respect to the variable x. V, the v function we are differentiating with respect to the variable t. This is the function u, this is the function v. This is the derivative of u, this is the derivative of v. U we are derivating with respect to the variable x. V we are derivating with respect to the variable t. Then we are finding the product. dv by dt into dt by dx. Finally, dt cancel. We have dv by dx, which we have differentiation of the function here. This is nothing but called chain rule. This is nothing but called chain rule. Using the chain rule, we can differentiate a composite function. Instead of that chain rule and the composite function, this procedure very easily also we have two methods. One is, this is the method definitely this method you may feel a little bit confusion. Instead of doing this method, directly we can differentiate the composite functions. So how to differentiate those composite functions, that and all we see in our next class. Hari Om.